All right, all right, all right. Excuse me. Welcome back. We should be live. As always, I'm going to double check that. All right. Looks like we are live. Okay, so we are back after being out for the whole of last week because I was sick. I actually had COVID. So, yay. As you can imagine, it wasn't that fun. But I survived and I'm here. Um, I was originally going to actually stream yesterday, but then, stuff happened. Uh, I had something to take care of, which basically meant that I couldn't actually find even 1 hour to stream yesterday. So, anyway, in any case, so we're back. We are going to continue with the FizzBee stuff. I think last time we did the very first getting started tutorial of the documentation. So this time around, we are going to take a look at guard clauses and the conditions relating to them. And I think that was understanding that took a little bit of time, or at least it was one of the things that made it challenging to solve even the very first exercise. So yeah, I mean, I guess that's the point of going through the material, right, or the manual, understanding just how everything works, and yeah, I mean, modeling concurrency in general is it's a trial by fire experience, at least for me. And based on what I've heard from several other people, it tends to not be a straight what's the word? Anyway, I think you get the point. But I mean, the only way to get better at it is to just keep doing it and keep learning from the mistakes that you make along the way. And I think for the very first exercise that we worked on, I think it ended up being that there was the key thing that was missing, was that I was missing out on some state that was not explicitly mentioned in the problem statement, but once you see it, it's like, well, yeah, duh, like, like, of course, this is something that should have been that I should have caught. It's like one of those things. It's like a mathematical proof. It's like, it's one thing to read a proof and be like, oh yeah, I mean, that makes sense. Like, you read the proof and you're like, okay, yeah, like, that makes sense, that follows. But that's not the same thing as actually writing the proof. Like, it's very easy in retrospect to read a mathematical proof and be like, oh yeah, like, all of this makes sense, and of course, you're taking this route and doing this and that. But the exercise, or the activation to actually compose and build the proof, that's another story. Like it's not so obvious. Um, anyway, all of that is to say that I struggled to come up with the right answer. In the end, I was not really able to. Um, and but I also learned that I took something away from it, basically. Anyway, so we are moving on, and today's focus will be on the God clauses, and yeah, we'll take it from there. Okay, God clauses and enabling conditions. Before you do any serious modeling in any formal system, you need to understand the concept of God clauses and enabling conditions. God clauses or enabling conditions are the predicates that tell whether an action transition is allowed or not. God clauses are critical to test deadlocks and liveness properties. Now remember, liveness properties. So when we are trying to assess, or I guess prove correctness of these models, there really are two things that we are looking at. We are looking at the safety properties and the liveness property. Safety is really that nothing bad happens, right? That's the simple way to put it for the safety properties. For the liveness property, it's really about something good eventually happens, right? I feel like there's one example that I came across recently that really helps. I can't really remember from the top of my head, but the idea is that it's possible to have a system where like when you're trying to think about the difference between safety and liveness, one thing that can help, right, is to think about the fact that you actually need both, because it's possible for a system to be safe, as in have safety properties, even strong, really strong ones, but it doesn't actually do anything, right? Like if you go to the Super Bowl, you can have the best defense ever, but at the end of the day, if you're gonna win the Super Bowl, you actually need to have your attack needs to be able to do something. At least that's my understanding. I'm not a big football fan. I just kind of sometimes sit down and watch it. I barely understand the rules, and in all the years that I've spent looking at it in any shape or form, I've never felt the need to really learn the rules. Anyway, but my understanding is that you can have the best defense there has ever been, and I think that this applies to a lot of other sports like soccer, football, the real football. You can have the best defense ever. If you're in a final and you need to win, you need your attack to do something, right? Like you can't defend forever. That's not how it works, or at least that's not how it's supposed to work. In soccer, you can possibly get away with it, because if it's a final, if you really believe in your defense, you can you can defend, all the way to, for 90 minutes, then 30 minutes after that for extra time, and then penalties. And then at that point, you're basically trusting that you have a near perfect record, and that your goalkeeper is going to do something miraculous, as in, stopping as many shots as possible, or as many penalties, or that the other team really sucks at penalties. So that's one way that you can win, by just having the best defense and having basically a zero attack. But that's a very contrived scenario. Like it happens, but it's so rare, and it's also really frowned upon in general. It's usually uh, referred to as parking the bus. I like how I'm going into a whole soccer thing while talking about uh, system modeling. But the gist of it all is that when you're modeling things, the systems, you want to think both in terms of safety and liveness properties, because you can have safety, but the liveness property is what really tells you that, well, this system is actually doing something useful, and eventually something good will come out of it. So yeah, that's my understanding of why you want to really think about both. It's not enough to just think about just the safety properties. You also want to understand what are the liveness properties of the system. Okay. All right. Here we are. Some formal methods, languages like EventB, Prism, etc. use standalone guard clauses or preconditions. FizzBee follows languages like TLA+. This is a weird phrasing. FizzBee follows languages like TLA+, by, I feel like maybe there's a by missing here, by using embedded guard clauses where the guard is part of the action. Oh, okay, yeah, because it's inside. Like it's not an externalized precondition. Basically, I think that's what they're trying to say. Like, I think recently I read how somebody was explaining the idea of when you're doing, I think it's called usually contract based. I don't think it's. I don't hesitate to call it contract-based programming, but the idea of the contract is that for every function, and I think if you've come across something like Ada, program language, I mean, I think YML also has it pretty extensively. I mean, anything that does. Well, not anything, obviously, because FizzBee does it by embedding the guard. I'm talking about cases where the guards are, I don't know if that's the right way to say it, but I guess externalize to the function. I think Daphne also has it that way. Like not embedded, I mean externalized. Let me see. Yeah, so this requires here, that's what you will call a precondition, and it ensures that's a postcondition. So as you can see, like it's like part of the actual how do I explain it? Declaration of the function. Like it's not embedded within the actual body of the function. Although, one thing to also keep in mind is that for a language like Daphne, I think YML has the same thing. They do these things where they have loop invariants. Oh, I think it's not. I don't know if it's only loops. Maybe it's also, it applies to just scopes within the actual body of the functions. Actually, in this case, we should call it method. I think Daphne is very a method and a function are not the same thing. At least based on the last time I scanned the language. So I don't know if these invariants are specifically only done within the body of the function like this for loops. I think maybe they also do it for just scopes within different scopes within the implementation of the method. Don't quote me on that. I think Y3 also does its it has a similar syntax with preconditions and postconditions and loop invariants. Gosh, I can't talk. Loop invariants. No, loop invariants. Sorry. Yeah, so this will be a loop invariant, for example. So this will be a so this here will be a precondition. So requires a preconditions, postconditions, I guess. Instead of ensures, I think this uses returns. I could have sworn that they used the keyword ensure as well. Yeah, they use ensures. So they have requires, they have ensures, and I think they also have returns. By the way, I don't know, I have something, I guess because it really looks a lot like Okamo, but I really like the aesthetic of YML. I don't know, it just does it for me. Yeah. Yeah, I think it has something to do with the fact that it looks a lot like Okamo. Yeah, I think if I, well, yeah, no, it is a completely useless opinion because I haven't professionally worked with either one of them. But I feel like if I had to choose one to, just from a vibe and stylistic standpoint, which again means nothing, I think I'll go with YML. I don't know. You know how sometimes you look at a language and it just feels nice, good, it's pleasant. I think that's the word I'm looking for. Like, C++ is not a pleasant language to look at, right? At least if you're writing anything that is sufficiently interesting and complex, I guess. At least in my experience, it's not a pleasant language to look at. Python is a pleasant language to look at, which, comes with, there is a cost to using Python, but it's useful. It's really useful, and it's just, I don't know, it's pleasant to look at. TypeScript it can be pleasant to look at, but it's also, I don't know, things can get crazy with the type definitions and generics and all that. It can be pleasant to look at TypeScript. Anyway, so to come back to our domain here and what we're looking at. So the difference between embedded and I guess not embedded gods. So I was just showing examples that I know of, right? At least based on my understanding. And I think the first one that I Googled was Ada. Ada also has pretty good, formal methods stuff. Uh, I just wish it was. I don't know. I get the feeling like it's. I feel like that's the sense that I get. I never done any deep research on it, but I feel like some of the like really high quality tooling around it is not open source. I mean, I see some of this stuff here, but I think the high quality tooling that companies actually use seems to not be open source. I could be totally wrong, but that's the vibe that I got when I looked into it some years ago. Um, but if I'm not mistaken, I think Adacol recently did some sort of merger, and now they are and now they're leaning into Rust quite a bit. Yeah, Adacol and Code Secure merge to form global company providing. Yeah, I think recently I get the feeling that they've started to make some headway into Rust. Uh, I guess in terms of adaptation and adapting Rust to some projects. And I mean that's a good sign for Rust. It's one of those things where I don't know. I think some of the I don't want to call them haters because I think some of the points that are made are um, some of the points that they make are well accurate, but um, at least depending on who you ask, I guess. It also depends on your level of experience with the language with Rust. Um, some of the criticism are uh, uh, I guess what's the word I'm looking for? Um, some of the shades that are thrown to Rust is, oh, who's building anything useful or important in Rust? Which, there are lots of things that are being built in Rust. But I think in the space of embedded software and just real time critical stuff, or just robotics, I think C and C++ are still like way ahead. But I think a company like Adacor starting to really push for Rust is gonna make a big difference in at least for the mission critical stuff. It's gonna make a big difference in helping Rust penetrate that specific domain, which I think is a good thing. Yeah, I mean C, C++, Rust. I think that's a pretty good trio uh, to have. Um, yeah. Anyway, okay. Uh, let's get back to this. But unlike TLA Plus, FizzBee infers the enabled status of the action using a simple but unconventional set of rules. This is our stuff from last time. So clear that out. I'm gonna close these so that I don't accumulate tabs for no reason. Okay. Sorry, just double checking some stuff. Okay. Sorry. Example, simple light switch. Let's run that in the playground. Oh, I thought I guess I didn't need to do that. Oh, wait. What happened? Ah, never mind. Okay. So we run that. We'll usually get the output somewhere here at the bottom. Yep. Okay. So the deadlock was detected. Model checker failed. Okay. And why did it fail? So when we initialize this, we start with off. And then we have the atomic action. This is the guard that we're about to talk about. Or at least what this chapter is about. And this is basically, obviously, just toggling between off and on. If you enter here and it's not on, then switch it to on. So you do the thing, you enter on, it's off, you switch to on, but then nothing else happens. Actually, why does that fail? Oh, because once it's on, there's nothing to switch it back to off. Basically, if I remember right. But then I'm not necessarily sure why that's a bad thing. We're about to find out. When you run the model checker, it will show a deadlock error because once the switch is turned on, then no other action is possible. Yeah. Obviously, two correct ways to fix this, depending on the requirements or the expected behavior. Well, okay, before we go into that, why is this fundamentally wrong? I mean, once the switch is turned on, then no other action is possible. Is that such an impossible scenario? I mean, if you take something like a lazy static in Rust, right, where lazy static allows for static variables whose initialization requires runtime execution. This is particularly useful for heap allocation, blah, blah, blah. So if it were the statics itself, the actual initialization of the inner variable occurs only upon the first access, yes, and subsequent accesses directly retrieve the already initialized value. So the idea here is that it's a value that only gets activated, if you will, once, and then that's it. Like, it's static from that point on. So, when you think about something like lazy static, you wonder, why is this fundamentally a bad thing? I'm not sure, but it's not obvious to me why this is considered a model checker failure due to deadlock. Anyway, well, I guess but then again, we do not specify any liveness property here. I guess I'm actually reading the what is it called? The Art of I'm actually reading this book at the moment as part of Eat and Feel I hope I'm saying his name right. Uh, uh, there is a reading software reading club thingy that I follow, and that's the book that is being read at the moment. And in the very first chapter, one thing that they discuss is uh, the mutual, the mutual exclusion principle. Then after that, there's the uh, deadlock safety, and starvation. No, starvation, deadlock freedom, and starvation freedom. And I think, just generally speaking, from a multi-processing or multi-processor programming standpoint, those are the three things that you really want to watch out for, right? The mutual exclusion. Is it a property or a protocol? Uh, I'm just gonna say protocol. The mutual exclusion protocol, and the deadlock freedom, and starvation freedom. So if I'm interpreting what this failure is about, is the fact that we basically are violating the second one, the deadlock freedom, because no thread in this case is making progress, and that's the deadlock freedom. Like, no thread that is enabled, or I guess willing to do work, unable to make progress. And you just need one to be able to make progress. As long as one is making progress, then you avoid the deadlock freedom. No, the deadlock. Oh, you have deadlock freedom. Or you satisfy the deadlock freedom condition or behavior. Now, if I think for the starvation thing, usually the starvation freedom becomes a byproduct of your deadlock freedom. But my understanding is that the starvation freedom is the idea that if a thread is ready to get work or to do work, it will eventually get work to do, right? So you don't end up in a case where you have 8 threads, but only one of them is doing the work, all the work, right? Like that defeats the whole purpose of multi-processing. Actually, let me Google this while we are here. Actually, let's type it here. Let's say, what's the difference between the deadlock freedom versus starvation freedom principles? So yeah, deadlock freedom, the system as a whole can always make progress. So yes, there's at least one thread that is making progress. Like that's the deadlock one. The starvation, yeah, every individual process action will eventually get its turn. Exactly. So again, if you think in terms of threads, like I said, in my example where you have 8 threads, but only one is ever doing all the work, and all the 7 ones are basically stuck, not doing anything. Now you're violating the starvation freedom principle. So you can have a system that theoretically, my understanding is that you can have a system that has deadlock freedom, but if doesn't guarantee, like in absolute terms, I guess, that by um, by solving the deadlock freedom, it's not an immediate guarantee that you also solve the starvation freedom property. Something can always happen, right? So that's deadlock freedom. And everything that wants to happen eventually will. So in FizzBee, I guess we're kind of jumping ahead by reading what Claude is saying here. In FizzBee, deadlock, for a deadlock, it automatically detects when no actions are enabled. When on actions enabled by default. Okay, require fairness annotation. Yeah, this one was giving us a run for our money in the last episode. Like, the fairness annotations. Yeah, fairness. So there's fairness and there's weak fairness also, if I remember right. Yeah, deadlock free doesn't mean starvation free. System progress, but some actions never fire. Starvation free implies deadlock free. If every action, oh, okay. I guess I sort of misspoke and probably I was dead wrong. Deadlock freedom does not often, because I think I said if you have deadlock freedom, then it's usually the case that you have starvation freedom. I should probably walk that back and say it's actually the other way around. If you have starvation freedom, then that it sounds like that. Well, I mean, it makes sense that it necessarily implies that you also have deadlock freedom, because if you have starvation freedom, then every one of your threads at some point, as long as they're up and running and ready to do work, they will get work. And so by that logic, it follows that you also don't have deadlock freedom, because for deadlock freedom, you only need one thing to be making progress in the whole pool of threads. Excuse me. Okay, obviously, so let's continue here. What time is it? Okay, 40 minutes. We are going a little slower than I planned, but that's okay. Okay, obviously, 2 correct ways to fix this, depending on the requirements or the expected behavior. Remove the guard clause from the on action. Okay. This will make the on action idempotent. That's like an elevator call button. You can press it multiple times, but it will not change the state. Excuse me. Allow other actions like off that will change the state back to off. Wait, but how does that actually solve that? Because if I remember right, earlier, by earlier I mean the last stream, when we were getting our ass kicked by all these with the starvation annotations or fairness annotations. My understanding is that the system may just fire off switch and then do nothing. So, okay. So this solves the deadlock problem, but it doesn't solve the fairness problem. Like you haven't solved the starvation freedom problem by adding this action here. But are we sure that we solved the deadlock problem? Excuse me. Well, once you off and you do decide to make you do decide to take an action, you have either one of these. This if you do decide to take an action, it will just be this one. Like the next, assuming that you go from init, either you play into the starvation thing, but assuming that it doesn't do that, it actually chooses to execute one of the actions. Well, this will be the one that's activated or enabled. So it picks that and it switches to on. But because there's no fairness, it could also just decide to stay there. And again, that's a starvation freedom issue. But if you were to decide to take an action, which is a possible path or a possible behavior, I should say execution path / behavior, then this will be what's enabled, and so we will do this. And if we remember again, for the deadlock freedom, the idea is that if you have, at least within the context of FizzBee, if you have an action that is infinitely enabled, then it should infinitely be selected. No, that's not the right phrasing. I forgot what the exact phrasing was, but I mean, in my head it makes sense, but now that I need to use the same word to explain it, it's not coming out the way I want it. Okay, yes, infinitely enabled, continuously enabled, repeatedly enabled. Yeah. So if an action is continuously enabled from some point onward, never becomes disabled, then it must be executed infinitely many times. A process that's always ready to run must eventually get CPU time repeatedly. And for enabled infinitely often, so it's infinitely enabled infinitely often. So this is basically if you switch a light on, that you never switch that light back off. It's just, it's on and it's ready to go. It's infinitely enabled. Then yeah, I guess for a process, if the process is always up and ready to run, then it must eventually get work to do. Enabled infinitely often, this is the case where it's switching between different values, but eventually it returns to that to a particular target value, which puts it in the enabled state. Then in that case too, it must be executed infinitely many times. Yeah. If a process that periodically becomes ready, or may block in between, or just go down and come, well, you should be careful here, because I guess once a process goes down, I mean, you can have a setup such that you're able to have durable execution, but usually from the native runtime perspective, I'm not talking about this durable execution frameworks or whatever. When you're working with, I don't know, barebone Python or Go or Rust, if your process goes down, you can restart it, but it's no longer the same process. So I think that's why they are careful, or there by there I mean Claude is careful to say blocking, like it's not saying that the process actually goes down and then comes back up, because that will be a different process. I think, especially from a verification standpoint. Well, actually, it depends on the level of abstraction and details that you're working with. Anyway, that's not the focus of today. Well, actually, it is, because this actually deals directly with the actions being enabled or not. Okay, so I was saying that basically I think this solved the deadlock problem, but it doesn't quite solve the fairness problem, or I guess the salvation problem. But then, how sure are we that it's solving the deadlock problem, though? Because again, it can initialize that off and then do nothing. But that's really the restoration issue. The moment that it's off, at least one action here is enabled, which is the on action. That one is enabled. So we have the infinitely gosh. Infinitely enabled and enabled infinitely often. Yes, so action on is enabled infinitely often. Same thing for off, right? Um, so when we start here, this gets enabled. And so if there is an action to be taken next, assuming that there's fairness, which is not explicit here, but let's say that we have fairness, then this will run. Wait, so what am I again trying to convince myself of? That we've solved the deadlock, that we have deadlock freedom, and I'm not 100% convinced that we are. Yeah, because we don't have anything here. None of these actions are infinitely enabled. So let me ask. Oh yeah, because these are. Oh yeah. This doesn't. Okay, even these two here that I've been reading. This is more for the fair versus weak fairness, strong fairness versus weak fairness. And this is the. Gosh, which one is which right now? Let me see. I think the weak fairness is for the second one. I think it's for the enabled infinitely often. And I think weak fairness is for the indefinitely enabled case. Yeah. In this particular case, well, I guess the way FizzBee works, can you have deadlock freedom without solving for starvation freedom? Is this running? Oh yeah, he passed. So we did solve for we did solve for deadlock freedom. There's only two states. Wait, but how is... Okay, I think we need to read more of this because I'm not exactly sure how that changes definitely solves deadlock freedom, or gives us deadlock freedom. Like, I get the concept that at each step, whatever action it does, it's able to make progress because at least one action is always enabled or activated. Um, what I don't understand, and this is from being scarred from the last exercise, is, well, there's nothing that here that compels it to actually choose to take an action, by my understanding, from what happened in the last exercise. I guess looking at this, once it gets to on, it can never actually be stuck at on. Unless it actually decides not to take any other action, which, again, by my understanding from the last exercise, is a very possible behavior. But it seems like I misunderstood that. Okay, let's read more. In an ideal world, you probably don't need to know this, but a brief understanding of the implementation details will help you spec the model effectively and help simplify the code and speed up model checking. FizzBee has multiple types of statements, similar to Python. One of the types is a simple Python statement that corresponds to a subset of Python's simple statement in this grammar. Specifically, we have assignments, store expressions, pass, del, other statements like if and else. Okay, there's one exception for the method calls. If the method call is to built-in functions or functions in a standard library, it is treated as a simple Python statement. If it is a user-defined function or a fizz function, even though it is syntactically the same as the built-in function, it's not treated as simple Python statement. Let us call it fizz call statement. In many rules, this exception will be a bit annoying to learn, but you'll get it once you see a lot of examples. In the atomic context, this is how the enable status is inferred. Every action starts out as disabled. Okay. Every action starts out as disabled. All right. So once it's been enabled once, so for this particular example, there's no way in which one action gets enabled without the other also getting enabled. Yes, but I keep coming back to the fact that it's in my head. I guess it's the fairness aspect that is screwing with my mind, I think. Okay, let's keep reading. Every action starts out as disabled. For each statement that is executed, if the statement is a simple Python statement, enable the action. Okay. FizzBee call statement, and the return value is assigned. Then enable the action. Excuse me. If require fails, disable the action and exits the action. For any other statements, leave the enabled bit unchanged. At the end of the action, if action enable equals true, the action will be added to the state graph and check for invariance. The rules are simple. The rules are simple and allows for an incredibly concise and expressive language. Okay, so action enabled false. Unchanged. Action enabled. And here becomes true. Oh, it's not this that enables it. It's this here. It's once you've actually entered the predicate block or the guard execution scope. I guess I can call it that. Then the action is enabled. If the switch is in off state, the on action will be enabled only when the switch equals on gets executed. Okay. If the switch is in on state already, the action starts out disabled. And since the switch on is not executed, the action will remain disabled. Yeah, but what are the implications of that? I think that's the part that I still don't fully understand. That is, the above code is equivalent to the following code. So off, if switch on, return. Otherwise, set it to on. Okay. Similarly, when you have if, elif, else, the action will be enabled only if at least one simple statement is executed. Of course, if instead of return, if you use any statement, it will enable the action. So action enabled false. This is a statement, so now it's true. Here it's true. A possible pitfall. Although the rule is simple, some seemingly equivalent Python code will not work as expected. For example, in this example, the on action will be enabled even if it's already on. Yeah, because this is a statement here. So even though the switch here, which is supposed to be, this predicate here it's supposed to be the guard, but you're using it as part of an assignment or an expression which enables the function or the action anyway. The reason is the isOn is a simple Python statement and enables the action when executed. Yep. It's a bit counterintuitive, but it is a design choice to keep the language simple and expressive. So, one way to still disable the action is to use require statements. Okay. In this case, when the switch is already on, when it executes the first statement, the action will be tentatively enabled, but the require statement will disable it. And since it aborts the action remains disabled. Oh, and okay. So also when an action does not get enabled, then it becomes disabled by default. I think that's what the rule was, right? Let's look at the rule again. Or rules, I should say. Yeah, if require fails, disable the action and exits. If it's a FizzCall statement and the return value is assigned, then enable the action. If it's a simple Python statement, enable the action. Okay. Oh, I think we made it to the end. This equality applies to for, any, while, function calls, etc. If within a for loop, if there is at least one simple Python statement executed, the action will be enabled. If the code calls a fizz function, I don't know if you guys can hear this, but my cats are having they're doing fisticuffs. It's so annoying like that sometimes. Don't know what they're fighting about. Alright. If the code calls a fizz function within the function, yeah, okay, we already read that. Alright, I think. Oh. Sure, let's go through this. Config and front matter. Wait, so for the last one, where did we? Okay, guard clauses. So we have the rules as far as, when an action gets enabled and how that relates to the guard clauses. What else did we learn? We reiterated, by way of reading this, we reiterated the idea of strong and weak fairness as the way it's interpreted. Wait, what? Interpreted. In FizzBee, right? The whole infinitely enabled and enable infinitely often thing. The fact that actions are disabled by by default, and it takes an expression. Right, these are the three rules for understanding whether an action is activated or not. Right. Yeah. Okay. Let's try to go through another page before we call it. And it's the FizzBee part of things. Config and front matter. FizzBee has some additional features and configurations that can be enabled via YAML file. The configuration can either be set with fizz.yaml or with front matter in the markdown file. In the online playground, it doesn't support fizz.yaml file yet, so front matter is the only option. Front matter is a block of YAML at the beginning of a file that is used to set variables for the page. The front matter must be the first thing in the file and must take the form of valid one. Yeah, I think these are pretty familiar things that people do for YAML files or configuration stuff in general. The available options, liveness, yeah, we'll come across this later, I think. Yeah, so again, deadlock detection. So you want to check for deadlock freedom and starvation freedom. Okay. Deadlock detection. Try this simple example. When you run this, it will show a deadlock violation because once X, okay, that's actually X0 require X less than 5. Doesn't matter that this is not atomic, as in this statement can be, I mean, between these two statements, something else could have happened, like another action could have happened. I mean, there's only one, so there's only one action, really. But I mean, still, yeah, anyway, let's not overthink this. So we start at 0, so this will be enabled when we enter here, and we add +1. It will still be enabled until we actually get to 5. And then it will bell and not be enabled. And now you can't make any progress. Let's see if that's what they say. Okay, when you run this, it will show a deadlock violation because once X, which is 5, okay, the increment action gets disabled and no other action is possible. All right, I'm starting to get a hang of this. I mean, it seems simple, but you know, it's concurrency. I don't know. It's a different way of thinking from just sequential, thinking, and there are rules to this game, and I don't know, I'm finding that it takes some time to really internalize them. Sometimes it is useful to disable deadlock detection, so just add I'm not gonna do that. I'm just gonna trust that it does what it says it does. Uh, Max actions. You can set the maximum number of actions to be executed in a path to, so default is 100, or the maximum number of concurrent actions, 2. Okay. Oh, and you can set configurations per actions as well. Okay. All right. I think we'll pause here for the FizzBee stuff, and next time we'll pick up with liveness and fairness. This should be really interesting. I think it'll give us even more of an understanding of, you know, the intricacies of trying to model concurrency. Liveness and fairness is, really important to understand. All right, let's see. What can we quickly look at, think about? React. Yep. About. Oh. I don't know. Let's see. I have some YouTube things open here. Let's see, what do I have open? No, not that. Let's see, I feel like I want to end the streams now by doing one or two, like, reaction things. Let's see.
When it comes to using things like Obsidian, I'm really great for like 1 day or 2 days.
Yeah. I feel that in my soul. Like, I mean, more power to people who can, like, meticulously organize their notes and, do all the things and use the notions and, the whole second brain thing. I think it's starting to calm down a bit, because I feel like a few years ago, 2 or 3 years ago, maybe even 4 or 5 years ago, there was all this craze about, you need to maximize every fucking seconds of, of your being, and this whole idea of the second brain and all that stuff. I feel like it's calmed down a bit, but, if I think the people who the whole second brain thing resonate with, they tend to, use all these tools and do all kinds of, notes, systems, and whatever. And I'm like, I don't know how y'all do that, because I think even all the way back, like in school, I was not great at taking notes. It was actually a point of contention with my dad, and also some of my teachers. Like I just like to sit and just listen, and that was both good but also bad. Um, anyway, uh, yeah. So basically, I can relate to what he's saying about how after one, two, maybe even a week after that, it's like it actually becomes a chore, right? Like it's just another thing that you have to do in order to actually get the benefit that you're looking for. And I think for some people that's fine, like it works for them. But for somebody like me, yeah, it's not so
But
much.
then
It's
I
not
just
fun.
forget, and it's just not a part of my schedule. And I've never found that taking notes have helped me internalize knowledge better.
Yeah.
Writing something down sticks in my brain, but typing in a computer for whatever reason just doesn't have the same feel. I would rather write things down on paper and throw them away than write them into a program like this.
That's a bit extreme for me. I think sometimes, uh, like I don't think I need to write things down by hand specifically to be able to remember them. I think I'm fine taking notes here and there as long as it's not a whole ritual. Like, and maybe that's a problem. Maybe it does need to be a ritual, and I need to force myself to make it a ritual. But like as far as a base like setting, it's not a ritual. Like okay, I can take a note here and there, but unless it's something that like unless it's something that I'm like, okay, I'm gonna get to this like tomorrow or the day after, and it's placed somewhere where it's like it's right there with, related to the thing or close to the thing that it's actually related to. Um, Unless it's like that, then it's not that useful to me. Like just having a whole other system to manage notes and all that, it's never worked for me. So you know, to some degree, I can relate with what he's saying here.
Want to love Obsidian. I want to be someone that can organize my thoughts in this really highly organized way, but I just don't think I'm capable of it. As many times as I've tried, and
Yeah,
I'm willing to try again and again, and I
yeah.
will continue to keep trying until I figure this out or I die. When it comes to using
uh, some things
every single software project follows the same rule. The first 2,000 lines, it doesn't matter whether you handwrite it
Oh,
or
it
you
feels
type it,
good.
it's all the same. If your project's only 2,000 lines of code, it's easy. But once
Yeah.
it starts growing, once it gets past that, something kind of magical happens. And at 10,000 lines is where the maximum magic is. And what is that magic, of course? It's the y-axis, which is regret. You regret every single
Yeah. It just sets in. Especially when at least, and this what I'm about to say usually happens when you haven't accumulated enough experience. And you're kind of a new hire. Well, usually a new hire, or you've been there not so long. You start getting ideas about how to do things and how you can make it better because you've read some blog post somewhere or whatever, you listen to some conference talk, or you know whatever, some framework du jour came out and it's cool and hip, and you decide, you know what, we need to rewrite this, or we need to do XYZ, like a wholesale, just rewrite the whole thing or whatever. And usually it starts out great. You're feeling great. You're getting that dopamine hit. It's lit. You know, all the bells and whistles that you heard about, like you get to play with them. It's nice. You feel good. You feel like, yeah, like, you know, You're doing something, you know, and then you get to a certain point where you realize, ah, oh, shit. It's funny. Like sometimes you get to a point you realize, wait, I think I'm just kind of doing exactly the same thing as before. Like whatever I'm putting out right now, it's not actual. Like if you're being honest with yourself, right? Because there's also that denial, right? Oh, don't you gotta watch out for that denial. That's if you what he's explaining. That's if you're honest with yourself. But it's possible that you might be in denial when you get to the 10K and you're telling yourself, this is going great and what I've done is actually better than we had before. But it's also likely that if you decide to be honest with yourself, it's likely that what you've done is not actually better. In fact, sometimes it's kind of worse. Because now you've done things in a way that may include some unintended consequences. Because there's a reason why software becomes legacy. It's usually because, despite its faults or whatever, it's making money. Like it's the thing that's printing the money, and that's why you don't just do a rewrite because you feel like it or because you think you have a better idea or whatever. Because the thing that's running today, it's making the money, and with that comes some character, right? Your software can have character, like it has its faults, and sometimes the business figures out how to turn bugs into features in a way. And by you trying to rewrite the whole thing, you get to a point where, yes, maybe you manage to do sort of a one-to-one mapping, but in doing so, you've also neglected to address some, hidden uh, uh, bugs or contingencies that are in the old code base. And until you get to production, you realize, oh wait, like there's this very super super unusual edge case that nobody will normally think of, but now it's here. And depending on what it is, it can be really bad, right? So yeah, it's nice. I swear, starting. That's why the whole vibe coding thing and the AI hype machine is so effective, because it really sells you on this idea that you can just produce code and just put start things anew, and it's greenfield. It feels nice, but you get to a point and you realize, oh shit, this is not like you're starting to lose steam, right? It's like, and I like how he drew this. If you think about yourself running, right? You're running, and then you start getting on that slope here, and you realize, oof, okay, this is not as fun anymore. And I think there was a post recently on Reddit about vibe coding that also explained this, where it's like the guy was saying how the person was saying how vibe coding feels great, you get started and all that, but then he asked, what's the point of vibe coding if I'm just gonna end up, like, I'm gonna get to a point where I'm just gonna end up having to pay a developer to deal with a code base anyway, because it gets to a certain level, right? It gets to a level of complexity where it's like, oh shit, okay, right? This is no longer demoware. Like, this is an actual code base that now needs to be maintained, and so you end up having to hire a software engineer anyway. And so now the question is, what was the fucking point of vibe coding? I mean, I guess the fucking point is, okay, you were able to prototype stuff and all that. But when we think about just the overall software engineering uh, um, work that gets done for software to run and be in production and have stability, reliability, and have paying customers, vibe coding can only get you so far. I don't know if I can find a comment. I think I saw it on Twitter recently. Vibe coding is all fun and games until you have to vibe debug, vibe refactor, and vibe deploy. Yeah, that's like yeah. Even just let's forget about vibe refactor and even vibe debug, right? Like if you were truly vibe coding, I mean, even before vibe coding, people already had trouble debugging, and that's usually code that they've written or other humans have written. Now, the idea of debugging code that was like, mass generated by AI, I can tell you, that doesn't sound fun at all. Vibe coding, vibe debug, that's perfect. I love this. This is it. This is the one. When somebody asks you about vibe coding, show them this. This is it. It starts out well. You're feeling good. You're feeling fresh. You're on top of the world. You're a prophet. You're a god. You're untouchable. And then you end up here. I'm stuck. Google off. Is it coming? Why are you rolling your own off? I mean, if you have a knack for vibe coding, you probably shouldn't be rolling your own off. Wait, what am I saying? Oh yeah, no. If you're vibe coding, do use, don't vibe code your own off. I guess that's what I'm trying to say. And the fact that you're stuck in Google off, I mean, it's kind of a good sign, right? Because you're trying to use Google off. Now, of course, you can then talk about, you could probably use some SaaS, something like WorkOS or whatever, or AuthKit or whatever. Anyway, can you explain how vibe coding works? Okay, yeah, this is the one. This is the one. Yes, we found it. What's the point of vibe coding if I still have to pay a dev to fix it? What's the point of vibe coding if at the end of the day I still gotta pay a dev to look at the code anyway? Yep. Sure, it feels kind of cool what I'm typing. Oh, I bet it does. Trust me. I bet it does. Well, except you're not even typing much, right? Or at least you're not coding or even programming. You're just natural language, right? You're just saying things and you feel like freaking Doctor Strange, right? You just move your fingers, type some English words, and voila. Like, it just happens for you. So I'm sure it feels really cool. Like having some flow state or whatever, you are not. That's not actually flow state. And if anybody says otherwise, they're lying. You typing a bunch of stuff, going back and forth with Claude, that's not flow state. I'm sorry. It's not. And it's also part of the reason, or it's also the reason why when people there's this whole like thing where people are like, oh, I can launch like 12 different cloud instances, and it's like, ooh, automation, everything is just getting done or whatever. Yeah, that's not how the human brain works. Um, like, I'm not saying that you can have a system where you're making use of multiple agents in parallel at the same time, whatever. But like that takes some work. Like you really have to think about an overall system to make that work in a way where it doesn't actually become a bottleneck, um, because you know parallel computing is just hard in general, and to get it right. And a lot of planning is also just a human problem. It's not really a machine problem. It's just a problem of actually, it's not even about the fact that you can build stuff. It's about what to actually build. Because there's a cost associated with all these agents that you're launching, right? Um, yeah, so I don't believe in this whole preaching of launch 1,000 different agents and it will have all the work in front of you. You feel like some sort of hacker with a bunch of screen and everything is happening. That's bullshit. That's not. Yeah, like if you're really, really good, right? Like you're actually better off just being single threaded, focus very like intently on a very specific task and going back and forth with Claude Code or I don't know Cortex or whatever agent, and getting that done as quickly as possible with the least amount of back and forth as possible. Then trying to launch I don't know how many dozens of agents to get work done in parallel or whatever. I think that's just, yeah, it's just some make believe, like some marketing thing that people are buying into. I don't buy it. Like that's just not how the brain works. Like you truly need to be focusing on one thing at a time and really do that well. Um, Everything that we know about computing is that multitasking is just hard. Like multi-processing, multi-threading is just fucking hard, right? Um, like you really have to think about how you or what you're building and how to organize that work. And sometimes you're just better off just completely focusing on one thing at a time and getting that done before trying to move on to something else. And even doing that with an agent, I don't think that you really enter flow state because the way, and I've used Cloud Code, Cloud Code myself. It's hard to truly enter flow state because there's that back and forth that is happening, and at any point where, because you're not, there's an element of passiveness of just being, you're not fully activated, even though you think you are. You at least from my personal perspective, you're not. It's not the same thing as when you're actually programming the thing yourself, right? You're not fully activated, which means that depending on the environment that you're in, you're very susceptible to just being distracted and your mind being pulled into different directions, right? Because in your head you're telling yourself, oh, it's okay, I'm just gonna type this thing, I'm gonna switch tabs, do this other thing, and then you couple that with the whole human in the loop UX of AI agents, where for a lot of things they need to ask for permission before they can move they can move ahead. you end up in situations where you give a command, but then you go back and you go away and you go back, you come back, and you realize, oh wait, the agent is stuck, either asking for some sort of feedback, or it's actually stuck trying to find a solution because it's iterating, and whatever, going in circles. Um, and then now you have to recontextualize everything, not only in your head but probably for the agent itself, and then sometimes there's no way out of it. The agent is just screwed, and sometimes you just even have to restart the session or whatever. uh, and that happens, like, that is so much of the experience, right? Like, it's baked into it, that I just don't believe that you truly enter flow state. Like, that's my take on that particular thing. That the marketing is selling you on the ease of things. Like, it's effortless. You just make things happen. And I think on paper that sounds good. It feels great. But I think long term, that is not. Like, that's just not great. From a, I don't know, overall just professional development. Yeah. Anyway, but when stuff, okay, like I'm in some flow state or whatever, but when stuff breaks, it's just dead weight. I can't vibe my way through debugging. I can't ship anything that actually matters. Uh, yeah. Yeah. Like, it's gonna be so funny for this to really become the reality that a lot of people come to realize. Like, the idea that just because you're producing code doesn't mean that you actually are shipping anything that's truly worth, or things that will endure, basically. Okay, so I can't vibe my way through debugging. I can't ship anything that actually matters. And then I'm back to square one, pulling out my wallet for someone who actually knows what they're doing. Makes me think vibe coding is just role play. Yes, a lot of it is. For guys who want to feel like hackers without doing the hard part, am I missing something here, or is it really just useless once you step outside the fantasy? You have discovered the Achilles heel of vibe coding. Great for markups, terrible for production code. Hire a developer once the concept is proven. Yep, I think this is it. I think this is the right way to approach it. Like, it's fine to just quickly put something that is, for feedback or whatever, but it's just not. I wouldn't say that that's good enough, or it's good enough to just say that you can build entire products that are sustainable using just vibe coding. Like, at some point, I mean, vibe coding can get you started, especially if you're new and you're just trying to understand how things work, right? That's great. Like, it means that a lot of people would give themselves the opportunity to even just attempt to build things, which is great. But at some point, if you actually care about building these things that you say you want to build, right? You either learn to program, or somebody else who knows how to program will have to do it for you. The point of vibe code is to make the devs manual work take less time, not code an app for somebody who can support to ship. Yep, I agree with that take as well. I mean, according to marketing, yes. Right? This question here. Do people think vibe coding means not knowing anything about software? Yeah. If you just listen to the hype machine, the marketing hype machine, I think that's mostly the message that is being sold to people. You're realizing that the hype isn't everything it's cracked up to be. This is why people say that while AI is awesome, it's got a long way to go. It does. All right. So this was the Reddit post. It was just 1 day ago. I guess we never finished this.
You made during these first 2,000 lines when life was good and coding was easy. Every single software project follows the same rule. The first 2,000 lines, it doesn't matter whether you handwrite it or you vibe code it, it's all the same. If your project's only 2,000 lines of code, it's easy. But once it starts growing, once it gets past that, something kind of magical happens. And at 10,000 lines is where the maximum magic is. And what is that magic, of course? It's the y-axis, which is regret. You regret every single decision you made during these first 2,000 lines when life was good and coding was easy.
Yeah. All right. I think we'll call it. We'll call it a night. Yeah. So we'll be back tomorrow, maybe. Won't make any promises, but we shouldn't. We should be back someday this week for more streams, for more diminishing scale issues. All right. Good night. Good night.